let me take copper on treatment with HNO3. I shall give you the condition also. This is going to be hot dilute. Hot dilute. I shall also explain to you how to predict the product. This is going to be nitric acid. This is a copper. You will be getting corresponding salts of nitric acid. They are nitrates. So, it should be copper nitrate. Copper exhibits valency 1 and 2. The more stable one is going to be cupric. Mostly cupric salts are formed. Cupric nitrate, valency of copper is 2, nitrate is 1. Plus, I leave some space here, and I have to account for the formation of water. Now, the space is meant for the reduction products of nitric acid. I am going to write here the reduction products of HNO3. What are the reduction products of nitric acid? What should be the oxidation state of nitrogen here? X plus 1 minus X is equal to 0. So, plus 5 and plus 1 plus 6 and minus X. So, any other compound of nitrogen whose oxidation number is going to be less than 5, they are all called reduction products of nitric acid. Nitrogen, I told you, what are the various oxidation states of nitrogen? Oxidation state of nitrogen, you have starts, the least one is going to be minus 3, least one is going to be minus 3, and it could be 0, it could be plus 1, plus 2, plus 3, plus 4. Nitrogen is one element, exhibits variety of oxidation states. Now, the lowest is going to be minus 3, the highest is going to be plus 5. Shall we write a few examples? Can anyone give me the example of nitrogen whose oxidation, compound of nitrogen whose oxidation state is minus 3? Ammonia, good. Ammonia, NH3, minus 3 and plus 3. It is minus 3 because it has combined with more electropositive element. An electropositive element will have plus oxidation state, electronegative element will have minus oxidation state. Now, what should be the 0 as an element? As an element it should be 0 because it is not a compound. What is oxidation number after all by definition? It is the former charge on the element in a compound. In a compound. Since it is not a compound, the oxidation state by definition is going to be 0. Now, plus 1, this is called N2O. N2O is called nitrous oxide. Nitrous oxide. Nitrous oxide. The oxidation state plus 2. This is called nitric oxide. NO is called nitric oxide. Do not read this as no nitric oxide. NO is a nitric oxide. Plus 3 oxidation state, N2O3. You see here, the oxidation state of nitrogen is 3 and this is going to be 2. This is called dinitrogen trioxide or simply N2O3. I shall write the formula here. Nitrogen trioxide, nitrogen trioxide, or normally it is also called as dinitrogen trioxide. Dinitrogen trioxide. This example is repeatedly asked in all the examinations. Different oxidation state of nitrogen. This is going to be NO2. We know NO2 is going to be nitrogen dioxide. Earlier they used to call this as nitrogen peroxide. Nitrogen peroxide. It should be called as only as nitrogen dioxide. You have one more example, N2O4. How many oxygen atoms? 4 oxygen atoms. Therefore, how should it be called? Nitrogen tetroxide. nitrogen tetroxide. In fact, this is the dimer of this. Two NO2 molecule combine together to form one N2O. This is what is known N2O4. This is what is known as dimerization. You know what is dimerization? Two molecules combine together. When three molecules combine together, it is called trimerization. When many molecules combine together, polymerization. It is called polymerization. It is dimerization. And NO2, nitrogen dioxide, nitrogen dioxide. And finally, N2O5, we know this is going to be nitrogen trioxide, and N2O5 must be nitrogen pentoxide. Good. Nitrogen pentoxide. So, these are the various compounds of nitrogen with the different oxidation states, which changes from -3 to +5. Let me formulate one question before we come to the balancing of equation, and still we are yet to fill the gap here. We will come back here. It should be one of these products, of these different products 1, 2, 3, 4, 5, 6, 7, 8. You cannot put one here. One of these 8 compounds you cannot put them here, because I have to put the reduction product of nitric acid. What is the reduction product of nitric acid? Any compound of nitrogen whose oxidation state will be less than 5. That alone called the reduction product of nitrogen. Which of the, in other words, I can frame the question in a different format. Which of these 8 compounds is not the reduction product of nitric acid? Can anyone guess the answer? N2O5 +5. Nitrogen, what is the oxidation state of nitrogen and nitric acid? +5. Here also it is going to be +5. There is no change. Instead, if nitric acid is converted into ammonia, converted into nitrogen gas, converted to N2O, NO, N2O3, any of them excepting N2O5, all of them are called the reduction products of nitric acid. Because nitric acid here acts as an oxidizing agent. Besides being used as an acid, it is being used as an oxidizing agent. How do you know it is being used as an oxidizing agent? What happened to the freight of copper here? Copper is converted into, what is the oxidation state of copper here? It is going to be 0. What should be the oxidation state of copper here? Whatever be the valency. Now, how do you find out? You do not know the oxidation product of state of nitrogen here. How do I calculate here? For copper, let me take X here. I have to take nitrate as one entity. What is the valency of nitrate? How do you write nitrate? NO3 minus. So, we have to take oxidation state of nitrate as one single entity, Therefore, what should be the oxidation state of nitrate here? -1. So, let this be -1. How many nitrates are there? 2 nitrates here, -2. X minus 2 equal to 0. X is equal to +2. Now, you understand? Copper has changed the oxidation state from 0 to +2. Isn't it oxidation? Removal of electron. And since it is oxidized, this must be the oxidizing agent. Since it is an oxidizing agent, it behaves as an oxidizing agent. What should happen to the oxidizing agent? It should undergo reduction. Therefore, I must write the reduction product of nitric acid. That the reduction product of any of them can be generally the reduction products of nitric acid, not all of them, depending on the condition, products of nitric acid, I have already written it there. Generally, it could be NO2, or it could be NO, or it could be N2O, or it could be ammonium compound. You don't get N2O3, we don't have any examples with N2O3, we don't have any examples containing N2. These are the normal reduction products of nitric acid. Now, under what condition you are going to get NO2, I shall tell you. That depends on the concentration of nitric acid. There are two things. One is concentrate nitric acid and dilute nitric acid. And the temperature is also important. One is going to be cold, the other one is going to be hot. So, if you mix these two, I am going to get various 4 permutation combination, isn't it? Hot as well as concentrated, hot concentrated nitric acid. The other one could be cold concentrated nitric acid, temperature alone is changed. The other one is going to be hot dilute nitric acid. It is dilute but hot. And what is the other option here? Cold dilute nitric acid. So, depending on these 4 parameters, I will be getting here. Now, since it is going to be hot, let me take hot dilute, correct. Hot dilute invariably is equivalent to cold concentrated. The temperature is reduced, but the concentration is increased. So, that is being compensated, isn't it? The conditions are compensated. I have kept it hot, and if you are using it hot, you must use dilute. If you are going to use it concentrated, it should not be hot, because hot concentrated will always give you this. So, this is the product of NO2 when you are using hot concentrated nitric acid, and this is the product you are going to get when you are using hot dilute, which is equivalent to cold concentrated. Let me come back to this later. Therefore, can you predict the product now? Can you tell me the missing compound here under this condition? I am using hot concentrated or cold hot dilute or cold concentrated. What should be the reduction product of nitric acid? NO. See, for you to predict the product, I have been explaining this to you. If this is the equation, copper plus nitric acid to form cupric nitrate plus NO plus H2O. First of all, I must get the product of nitrate of copper. I should be able to account for water, and I have to predict the reduction product of nitric acid, and these are the various reduction products.